Exercise 11D, AASL, IB Oxford book. Question 1, a tree casts a 12-meter shadow when the angle of elevation of the sun is 25 degrees. So how tall is the tree? Let's sketch the problem. So let's say this is the tree, and then this is the level ground. If this is the top of the tree, so the tree will cast a shadow on the ground that they are saying is 12 meters. So let's say up to this point. So if this is the sun rays hitting the ground, the angle of elevation that makes from the ground should be 25 degrees. We consider the ground at the level, an eye level place. So we can use the concept of trigonometric ratios. So Katoa. So because we want the height of the tree, how tall is the tree? We will consider this angle as an adjacent, and we want an opposite side of it. So you're going to use tan. That means if we do the tan of the angle, should be equal to opposite divided by adjacent. So our height here is 12 multiplied by tan 25 degrees. So using my GDC, you can easily find what that 12 times tan 25 degrees is. So let me clear this. So we are going to write 12 times tan 25. And the answer is 5.595691898. Three significant figures, that should be 5.60 meters. So that is the answer we are going to write, 5.60 meters. So the tree is 5.60 meters. That is how tall the tree is. Number 2, a kite in the air has a string tied to the ground. So always model what is happening. Assume this is the ground, then this is the string going up where the kite is. The length of the string is 50 meters. We make an assumption that the string is tight and it is straight. Find the height of the kite above the ground. Then that should be this height, h, when the angle of elevation of the string to the ground is 55. So this angle of elevation to the ground is 55 degrees. Okay, this is the same concept as above, but let's see. This angle will require an opposite side, and we have an hypotenuse. So opposite and hypotenuse, this one should be so. So we can do the sine of that angle, and we equate it to opposite h of hypotenuse, 50. So how do we get h? You can do the reciprocal and divide by 50. You can actually multiply by 50 both sides for you to get h 50 times sine 55 degrees. There's no need of doing the reciprocal at that point, just multiply. So 50 sine 55 degrees, you can put it in a calculator. I'm just going to use a hand calculator I have. Then if for questions that require complex use of the GTC, will be using that. But this one you can multiply directly using your calculator. So I get my answer as 40.957602221. To three significant figures, that should be 41.0 meters. So find the height of the kite. So the kite is 41.0 meters above the ground. Question 3, so it should be up here. A 3-meter ladder rests against a wall. Okay, always model what is being said. So if this is the wall, and then this is the ground, and then we'll have the ladder. I'm going to represent it with a line with arrows on both sides. So this is a ladder which is 3 meters, leans or rests against a vertical wall, so that the distance between the base of the ladder, the base is here, and the bottom of the wall. The bottom of the wall is this part is 0.8 meters. So question A asks you to find the angle that the ladder makes with the wall. So the wall is here and the ladder is here. So this is the angle they both make. So let's call that theta. So for you to calculate theta, look, you have an opposite side and you have an hypotenuse. So opposite hypotenuse is so. We can do sine theta will be equal to opposite divided by hypotenuse, which is 3. So that our theta here will be sine inverse of 0.8 divided by 3. Yeah, use your calculator. This is a simple one. You can have the fraction 0.8 divided by 3, then do sine inverse of that, and you'll get your answers 15.46600995 to 3 significant figure that should be 15.5 degrees. Okay, for part B, find the height above the ground where the ladder meets the wall. So the height above the ground where the ladder meets the wall. So this is the height, should be the distance from this point up to this point. So we can call it h. There are two ways of this. You can use Pythagoras theorem, or you can use trigonometric ratios. So we can do h squared should be equal to hypotenuse squared minus the base squared. So that when you want to get h, just do the square root of the difference of those squares. So that should be 9 minus 0.8 squared. You do the square root. We're getting 2.891366459 to 3 significant figures, that is 2.89 meters. So the ladder is 2.89 meters from the ground. So that is number 3. Number 4, a man standing on a cliff looks down with an angle of depression of 40 degrees. Okay, so let's model that up to that point. So let's say this is the cliff, then this should be the ground. If this is the height of the cliff, the man is standing here. So let's say the eyes of the man are here. So this is the level ground. And let me put it a bit lower so that we can be able to have a good representation. Want an eraser. So it is always good to sketch. It will give you a vision of what is happening. So this is the cliff, and then this is the man. So if this is the height of the man, the eyes are here. You can call it a level, eye level from where the man is looking. So this is straight. And then, so the man standing on a cliff looks down with an angle of depression of 40 degrees. So if he looks down, we'll draw a line from here to here. So angle of depression is this one, 40 degrees from the level of the eye. The cliff is 80 meters high. So from here up to here, this should be 80 meters. And then the man's eyes are 1.5 meter above the cliff. So from the cliff to his eyes, it's 1.5 meters. How far is the boat from the cliff? So this is the cliff, and then this is where the boat is. So they're asking for this distance from cliff to the boat. Let's call it distance B. So if we check this, from the man's eye, if it is horizontal, it will meet this height from the cliff at 90 degrees. So because we have already covered 40, we will also cover 50 on this inner part. So 50 degrees on this inner part. Alternative of doing that, remember this is also 90 cliff and the ground meet at 90 degrees. The other concept you can use is the angle of depression should be similar to the angle of elevation. So this angle, if your eyesight is here and you go up, this should be 40 degrees. So you can use any of those property to get that. So we are looking for B. You can use trigonometric ratios. Let's see. So you have 40 degrees. You can use 50 or 40. Let's use 50. 50 degrees has an opposite side and it has an adjacent side. So we'll use tan of 50 degrees should be equal to opposite B divided by adjacent. Adjacent is 80 plus 1.5, the height of the man, which is 81.5 meters. So for you to get B, you have to multiply 81.5 by tan 50. You can simply use your calculator to do 81.5 multiplied by tan 50, and you'll get your answer as 97.1279 into three significant figures, just 97.1 meters. So we can see the boat is 97.1 meters from the cliff. Okay, that's number 4. Can look at number 5. Romeo stands 3 meters away. Romeo stands 3 meters away from the wall of Juliet's house. Juliet is standing on the balcony. Romeo raises his eyes 70 degrees to look into Juliet's eyes. Romeo and Juliet are both the same height. How far is Juliet's balcony? So we're going to sketch what the problem is saying. So Romeo is standing 3 meters away from the wall of Juliet's house. Okay, so let's say this is the level ground, and then this is Juliet's house. So Romeo is standing here. Let's say the ice is at the point I've circled, shaded. So if that is Romeo, and then standing 3 meters away, so this is 3 meters from the wall of Juliet's house. Juliet is standing on the balcony. So this is how high the balcony is. And let's say the balcony is at this point and Juliet is standing that balcony. And then Romeo raises his eyes 70 degrees to look into Juliet's eyes. So let's say this is Juliet standing here and her eyes are here. The eyes are here, so Romeo raises his eyes 70 degrees to look into Juliet's eyes. So if this is the eye level for Romeo, he will raise and he will look at Juliet's eyes, and the angle will be 70 degrees. Then Romeo and Juliet are both the same height. So that means if I compare these two heights, then this and this are similar. And then this will also be 3 meters still from where Romeo and Juliet are, 3 meters apart. So Romeo and Juliet are both the same height. How high is Juliet's balcony? Now, this 3 meters is the same as this height, 3 meters. And if this is the base of the balcony, we'll have an elevation to the eyes. Then from the balcony to the eyes, that is how far from the base of the balcony to where the eyes of Juliet are, that is how high the balcony is. So we are looking for this height, so we can use tan. Tan of 70 degrees will be given by opposite over adjacent. So for you to get the height, will be 3 multiplied by tan of 70 degrees. So if you use your calculator, that will be tan of 30, that tan of 70 multiplied by 3. So you will get your answer as 8.2424. So to the significant figure is just 8.24 meters. So we will say that Juliet's balcony is 8.24 meters. And then let's go to number 6. A boat travels on a bearing of N 36 degrees W for 25 kilometers. So this is compass bearing. So it is in northwest 36 degrees for 25 kilometers. So you're going to have a short sketch of that. So you're going to have a very small compass with an indication of north, and then this will be west. So northwest, it means it traveled this side, and it traveled for 25 kilometers. So this is 36 degrees. Travel for 36 degrees. And north, we'll have north going as this. And then if it ended here, we'll have another line meeting the true north. So 36 degrees northwest should be that angle. So part A asks how many kilometers north has the boat traveled. So they're asking what is the distance from this point up to this point where the boat stopped after the 25 kilometers. So we will use Sokatoa, and we have the hypotenuse of the triangle. Obviously they meet at 90, and then we need the adjacent. So adjacent and hypotenuse should be R. So cos, can do cos of 36 degrees should be given by adjacent, which is the height we need, divided by hypotenuse 25. So our height will be 25 multiplied by cos 36 degrees. So we're going to take 25 multiplied by cos 36, and you get your answer as 20.225. So to 3 significant figures, 20.2 kilometers. That is how far north it has traveled. Then how many kilometers west has the boat traveled? So west is towards the left. So from this point up to this point, what is the kilometers traveled? So you can use Pythagoras theorem, or you can use ratios. So let's call this B. Let's call this part B. So we are looking for distance B. So we can also use the angle. It has an opposite, and we also have hypotenuse. So opposite hypotenuse should be sine. So if we do the sine of 36 degrees, should be given by opposite, which is B, divided by hypotenuse, which is 25. So for us to get B, we'll have to multiply 25 by sine 36 degrees. And if you do that, you'll get your answer as 14.6946. To 3 significant figures, 14.7 kilometers. So that is how far it has traveled east. So that's for number 6. Let's look at number 7. A boat is due south of a lighthouse and sails on a bearing of 292 degrees for 51 kilometers until it is due west of the lighthouse. Okay, so let's say the lighthouse is here. It has its compass north, and also we'll have east, west, and south. So if this boat is now due south, it means it is directly on the south of the lighthouse, and then the boat also has its compass and sails on a bearing of 292 degrees for 51 kilometers until it is due west of the lighthouse. So 292 degrees, we said if this is north, we are going to measure our bearing clockwise from north. So let's measure 292. Let me pick another pen. So, okay, so from here, we have measured, already have 90. We already have another 90, that's 180. And then we have another 90, that is 270. We need 292. So the difference between 270 and 292 is 22 degrees. So you're going to measure 22 degrees on this side and then have the boat go to the west side of that. So remember, from here to here, uh this whole angle is 292 degrees. So the total angle should be 360 degrees. So if you subtract 22 or 292 from 360 degrees, you'll get that the angle remaining inside there is 68 degrees. So 68 degrees. So for 51 kilometers, so it will cover 51 kilometers until it is due west. So west of the warehouse is this side, and that is where the boat is exactly. So this is the lighthouse, and then this is the boat, and then this is the boat. So if you draw the compass at the point where the boat is, that is what you will get. So they're asking how far is it from the lighthouse. So we are calculating this distance. Let me call it B. So we have an angle inside here. It's a right angle triangle it forms. This is 90 degrees. Then this should be the hypotenuse, and then this should be the opposite. So opposite hypotenuse, that should be so, which is sine. So if you do sine of 68 degrees, will be given by opposite divided by 51. So 51 multiplied by sine 68. If you use your calculator to do that, you will get 51 multiplied by sine 68 is 47.86. So to three significant figures, your answer will be 47.3 kilometers. So that is how far away from the lighthouse the boat is. We look at number 8. Number 8 says Wally looks out of his office window and sees the top and bottom of an apartment block 300 meters away. Okay. With that in mind, we have a level ground here. We'll have a building where Wally is, and let's say this is his eyes, where his eyes is. So he sees the top and he sees the bottom. So we'll have this block here, which is 300 meters away. Yeah. Then they're saying the angle of elevation of the to the top of the office building is 23 degrees. So the angle of elevation to the top of the office building is 23 degrees. And the angle of depression to the base of the building is 30 degrees. So let's say this is the level I of Wally. This is the level I of Wally. So you can extend the level I to that. Let's start with the angle of depression to the base of the building is 30. So we are moving to the base of the building, that point. So this angle is 30 degrees. And then the angle of elevation to the top of the office building is 23 degrees. So for this case, we are going to draw where the angle of elevation is to the top of the office building. That should be from the level ground this guy will look up to the top of this building, and then the angle of elevation should be 3 degrees as required. Now, if we are very keen, they are looking for how tall is the apartment block. So we'll be looking for how tall is this apartment block. We'll have a very big letter H to represent the height of the apartment block. Remember, from where Wali is to this point is 300 meters, and also this will be 300 meters. And remember also, from the level I down to this point is 90 degrees. So we have already covered 30 degrees. Inside here, we still have 60 degrees. So we will require this height, this H, which is the same as this H here, because this is like a rectangle. And then we'll also require this small height here. Let's call it X for it to form the whole of a letter H. Since we already have an angle here, we need the opposite side and we have the adjacent side. So adjacent opposite or opposite adjacent, that is TOA. So we are going to say tan 23 degrees is given by opposite X divided by adjacent 300. So this implies that our X will be equal to 300 multiplied by tan 23. I want to leave it as that. I want to not to get the answer now because it can influence accuracy. So we have X value. Let's see how we can get the H value. H is here. So we need the adjacent side of the angle and we have the opposite side of the angle. That means if we do tan 60 degrees, it will be given by opposite 300 divided by adjacent, which is H. This implies that H will be given by 300 divided by tan 60 degrees. Okay, so remember, for us to get the overall H, we will need to add small h plus X. That means small h is 300 divided by tan 60 degrees plus 300 times tan 23 degrees. So you can use your calculator, do that. 300 divided by tan 60 added to 300 times tan 23. So you get 300.547 to 3 significant figures is 301 meters. So that is how tall the apartment block is. Okay, let's look at the next question. The next question is question 9 about the Eiffel Tower. Eiffel Tower is 300 meters above the ground. So Pierre is standing on the viewing deck of Eiffel Tower, 300 meters above the ground. He looks down with an angle of depression of 40 degrees. You see a lane at point A, looks down further 32 degrees to see by. So at point B, what is the distance from A to B? Okay. So we'll have these two people and we'll have to calculate the distance between them. That means we can only get, let me call this point T where the tower is. We will need the distance from B to T. And then because we can easily get the distance from A to T. So if we get the distance from A to T and we subtract the distance from B to T, we can get the distance from A to B. I'm using A, T, and BT because they lie in a right angle triangle, which is easier to use the trigonometric ratios we have. Okay, so maybe we can get this angle here, angle B. So we say angle of elevation is the same as angle of depression. So that will mean that this angle here should be similar to the angle here. Angle B should be similar to for this angle. And also you can say this is also 40 degrees because this angle and this angle are the corresponding or alternate, either of them, not sure about them. So 40 degrees and 40 degrees down there, and then 72 degrees and 72 degrees inside here. So we normally use the letter Z and letter F to represent those types of angles. So if you have a letter Z, those angles inside there are similar. Now, since you have the angles already, you are going to calculate those values of the missing side. So those should be alternate angles. Yes, those should be alternate angles. So 72 degrees is alternate to 72 degrees on that B, and then 40 is alternate to this 40 here. So we can start calculating. We calculate BT since we have the angle. It has an opposite side, but we are looking at the adjacent side. So opposite adjacent is TOA, TOA. So we can do tan 72 degrees is given by opposite 300 divided by BT. So BT should be given by 300 divided by tan 72 degrees. All right. So remember the idea for us to get AB, we are saying that AB will be equal to AT minus BT. So we already have BT. So we are looking for AT. Okay, so we have 40 degrees here. We have an opposite side, and then we need an adjacent side. So we can also use tan 40 degrees given by opposite divided by adjacent, which is AT, the whole of the right angle triangle. So AT for this case will be given by 300 divided by tan 40 degrees. All right, so lastly, our AB is 80, which is 300 divided by tan 40 degrees. 300 divided by tan 40 degrees minus BT. BT is 300 divided by 172 degrees. So use your calculator to do 300 divided by tan 40 and then subtract 300 divided by 172. Get your answer as 260.05. The three significant figures is just 260 meters. So that is how far those two people are apart. So that's the end of exercise 11D.